The unit circle, of course, is named that because it has a radius of 1, and that makes it easy to get the trig functions of your familiar 0, 30, 45, 60, and 90 degree angles because the radius is 1. You should be able to reproduce that unit circle in degrees or radians from memory, complete with the x and y coordinates, and you should also be able to give the sine, cosine, tangent, cosecant, secant, and cotangent values for any of those angles on that unit circle. And because of symmetry, as I mentioned before, if you know the first quadrant, then you can get all the others. And someday soon you're going to have to reproduce that unit circle or information on it without a calculator. So part of your first test is going to be to do that with no calculator. There's an interactive unit circle that actually will give you quizzes at this link if you want to practice on the degree and radian measure equivalents. So let's see how we do here. Find the exact values of cosine 135 degrees. Well, where is 135 degrees? It is 45 degrees from 180. So that means I'm in the second quadrant, and so I'm dealing with the ordered pair square root of 2 over 2, square root of 2 over 2, and the x is negative because I'm in the second quadrant. So the cosine is the x value, so I know the answer to that is negative square root of 2 over 2. Tangent of 5 pi over 4. Well, where is 5 pi over 4? 4 pi over 4 would be all the way over here to pi, and so I would go one more pi over 4 here. So I would be the 45 degree angle in the third quadrant, since both the x and y coordinates are negative in the third quadrant. I would have this ordered pair, and tangent is y over x, so I've got the same thing over the same thing, and they're both negative, so that tangent is positive 1. Sine of 315 degrees. Where is that? Well, I know all the way around here is 270, so 315 is the 45 degree angle that is in the fourth quadrant. In the fourth quadrant, the x is positive and the y is negative, and sine is y, so it is negative square root of 2 over 2. Find the cosine of 210. Well, where exactly is 210? Well, it must be beyond 180 because this is 180. So I'm going to go 30 degrees beyond 180. So it's a 210 degree angle, but what I'm really thinking about is from here to here is 30 degrees. So that tells me I need to call from memory the ordered pairs for 30 degrees. Now I can remember that it's 1/2 and the square root of 3 over 2, but which one is which? So mentally I'm going to sketch in the little triangle here and say, oh yeah, if it's 30 degrees, then the vertical that goes down to the axis is the short one, so the y is the smaller one, and the x then is going to be the bigger of the two. And let's see, I'm in the third quadrant, so they're both negative. So the cosine for 210 degrees is the x-coordinate, so that would be the square root of 3 over 2, and it's negative. Sine negative 60 degrees. Where is that? Well, that would be 60 degrees in this location. So I've got a 60 degree angle, and that means I'm going to mentally think of that little triangle and say, oh yeah, it's the 1/2 square root of 3 over 2 deal again. This time the y is the bigger one. So it's going to be 1/2 square root of 3 over 2. It's in the fourth quadrant, so the y is negative. And it just so happens that the sine of an angle is the y value, so this is negative square root of 3 over 2. Tangent, 5 pi over 3. First thing I got to do is think, where's 5 pi over 3? Well, 6 pi over 3 would be all the way back around here to 2 pi. So it must be pi over 3 short of 6 pi over 3. So that right there, from there to there, is pi over 3, or 60 degrees. So I'm dealing with a 60 degree angle again. In fact, I'm right back over here, same picture. So I know that this is 1/2 and negative square root of 3 over 2. Tangent is y over x, so it's negative square root of 3 over 2 over 1/2, which is just the negative square root of 3. So it's going to take some practice, but you need to be able to do all of those multiples of 30, 60, 45 degree angles all the way around the unit circle, and actually all the way, if it went multiple revolutions around, eventually if you stop at a 30, 45, 60 degree angle somewhere in there, you should be able to do exact values of those. For example, Sine 480 degrees. Where is that? Well, 360 is all the way around once, so then we're going to go another 120, which would stop 60 degrees short of 180. So here is 480, so it's going to be equivalent to the 60-degree triangle right here, or 120-degree angle. So, but what I'm trying to get is where am I on that unit circle and what are the ordered pairs? So I'm at a 60-degree angle in the second quadrant. 60-degree angle, the y is going to be the bigger value, so I've got the square root of 3 over 2 as the y value and 1/2 as the x, and the x is negative in the second quadrant. I want the sine, so it's square root of 3 over 2. Cosine 11 pi over 4, where is that? 12 pi over 4 would be 3 revolutions. Let's see, 8 pi over 4 would be, that's around once. 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4. So it is 1 pi over 4 short of being at 3 pi. So that means we've got a 45-degree angle right in here. So my ordered pairs I'm dealing with are the square root of 2 over 2, comma, square root of 2 over 2. And the x is negative because I'm in the second quadrant. I want cosine, which is x. So the answer is negative square root of 2 over 2. And one last one. Tangent 7 pi over 3. Pi over 3, 2 pi over 3. There's 3 pi over 3. Go all the way around. Here's 6 pi over 3. So one more pi over 3. It's going to be pi over 3 in the first quadrant here. So pi over 3 is a 60-degree angle. So I've got the 1/2 square root of 3 over 2 again. And I want tangent. They're both positive because I'm in the first quadrant. I want tangent, which is y over x. So square root of 3 over 2 over 1/2. Which reduces to square root of 3. So that's how I do all those. So you can see how important it is that you know where you are on that unit circle to be able to use the ordered pairs to find the sine, cosine, tangent, or whatever they ask for.